Hey everyone, welcome to another FPS tutorial in the Godot engine. Today is the beginning of our interaction setup, and when I say interactions, I mean things that the player can interact with. That would be maybe a door or a pickup like health or ammo. As always, the source files for the project are available on my Patreon, so you can grab those there. Otherwise, let's get started. Our goal for this video is to set up a raycast from the center of our camera that's going to tell us what it hits out in the world environment. Now, if you don't know what a raycast is, it's just a line in 3D space. It has a beginning point and an end point, and through code, we can check along that vector to see if we hit anything within the collision layer that we set. Our first step is to step into our FPS controller script. That's where we're housing our camera. And because we're going to be interacting in pretty much every state that we have, we're going to put this in our main controller script. And then we need to start with two different variables. One's going to be an export variable, and this variable will be our interact distance. This will be the distance that the raycast can go, and therefore the max distance that we can interact with anything. And then we need an empty variable that's going to hold the result of that raycast. But down at the bottom, we're going to add two functions to our script. The first is going to be an interact function, and we're going to run this whenever we press our interact button, which we're going to add in a second. And for now, we'll just add our pass to that, and then another function that is going to be run on every frame that is going to cast our ray. Now you can set up a raycast node up here in your scene. That works too. I like to do it in code because I know where it's at. You can control it within the script. And then you can also adjust a little bit more easily where it's coming from and where it's going to end up. Now we've done this before when we did our weapon, our shooting. So I'll walk through that process of creating that raycast again in script. To get started, you need a reference to the camera because that's where we're going to be starting our raycast and casting from. Then you need to get the space state. So we set a variable for that space state and set it to our camera, get world 3D. So get the 3D world that camera is a part of, and then direct space state. Next, we need to get the center of our screen. And we can do that by getting the size of our viewports. In fact, let me draw this out real quick. You can do that by getting the size of our viewport. Say that is our viewport right there. And let's say our width is 100 and our height is 50, and we want that spot right in the middle. Well, all we need to do is divide that by 2, divide this by 2, and that's going to give us right in the middle, our center spot. So we get the viewport with our get viewport function. We get the size property of that viewport, and then we divide that by 2. That's our screen center. Then we need the origin point of our raycast. We get another variable. We get a reference to our camera. We project ray origin, and we do that from the screen center, from the center of our screen. And we're doing the screen center because that's where our reticle is. That's where essentially the mouse is for the player. Now that we have our origin point, we need the end point of that ray. So we set another variable called end, and we equal that to origin, plus we're going to get the normal from our camera, and then we're going to add our interact distance to it. So to do that, we do our camera, project ray normal from our screen center, and then we multiply that by our interact distance. Now, if you're thinking about our beginning point and our end point, we need to get a vector, right? And that's what that normal is. So if our camera is going out like that, we get our normal to that point. So wherever we're looking with our camera, that's going to be where that raycast ends. With our origin and endpoint, we have the information that we need to actually do our query, our raycast. To do that, we set another variable. We call it query, and we use the physics ray query parameters 3D. We're going to create one of those, and it needs a from point and a to point, and our from is our origin, and our to point is our end. We also want to make sure that within our query, within our Raycast, that we're going to make bodies collidable. And we do that by setting collide with bodies to true. Our Raycast is now set up, and whenever we do our Raycast, we're going to get a result. And we need to get that result and put it into another variable. There's definitely a lot of variables involved. And honestly, what I would do probably in an end goal is take this whole thing and create a function within a global script so you can just call it whenever you want, not have to write this out all the time. But that's beyond what we're doing today. So we get our results, and to do that, we space state, get our space state, and intersect ray with our query. And our result variable now holds all of the information that we need. And specifically, if you go into this intersect ray, and you can click on this if you control and left click, you can see within our intersect array, we're going to get a lot of information, including the colliding object, the ID of that object, the normal of the surface that we're hitting at the intersection point, the face index of that intersection point, and the shape index of that colliding shape. So lots of information that we're going to be getting. And if it doesn't hit anything, it's just going to pass null. It's just nothing. We don't get anything back. And we'll have to account for that in a little bit. Back in our script now, we have our results, and we're going to get the collider. We want to get the node, basically, that we're hitting. And so let's do that with another variable, and we're going to call this current cast results, and that's going to equal result get collider. That's the extent of the function that we need to get some results. So let's go ahead and print our cast results, and let's test this out. We need to also make sure that we're going to be running this every frame. So let's go up to our physics process and add our interact cast function. And let's run this, and when we do, we should get some results down in our output. Now our Raycast is happening from the center of our screen, and we're currently getting a bunch of null values down in our output. Remember, we set our interact distance to 2. That means in 2 meters. That's as far as we're going with our Raycast. So we get a little bit closer to some objects, we're going to start getting some results. You can see our Raycast is finding and hitting our static body 3D nodes over here. Also remember that you need a collision object for the Raycast to do anything. And it also has to be in the layer that you're checking for. And this information is going to be exactly what we need when we continue our interaction set up in other videos. We just need to know what we're hitting and to be able to control the distance that we are able to hit those objects. So the fact that I can get static body 3D is perfect. Now that we're getting a result from our Raycast, the other part of the puzzle is whenever we interact, whenever we press, say, the E key, we want to take whatever we're hitting and be able to interact with it. So just for our setup, we're going to create an input map for a interact key, and we're going to print out what we're currently looking at, if anything. So we'll head up to our project settings, and input map, and then we're going to add an action called interact. And for this one, in fact, let me resize this a little bit. For this button, let's just do the E key for our interact button. Now to add our interaction, let's go up to this function right here. So this is the input function, and it's an existing function that is always there, and we're overriding it within our script. We're adding to it. And what this does is it fires whenever there's an input event. Now that's more complicated in terms of when certain ones fire. For example, I've got an unhandled input up there and an input. There's a sequence where these are set up, and I won't get all into that, maybe in a future tutorial video. But for now, just know that this is all going to fire whenever there's any input event at all. We're already using this to exit from the window, right? So let's add another one. So if the event is the action pressed interact, we're going to run our interact function right there. In our interact function, we're going to take whatever that current cast result is, check if it exists first, and if it does, we'll just print it out, okay? In the future, what we can do is access that node, that script, whatever that might be. Maybe it's a door or a pickup item, and we can run some code from there. For now, we're just going to print. And remember, we did create a variable up here to hold that information, and that's the interact cast result. So I guess the first thing we need to do, we don't need to print that. So the first thing we really need to do is get the interact cast result and set it to the current cast result. Now that variable, that information is accessible from anywhere in our script, and we'll check in our interact function if cast result is not null, and if it is not null, we'll print it. But only if we press the E key. So let's test that out. Head over to our boxes, and we took off our constant printing. So I'm looking at the box. When I press E, it should print, and there it is. And same goes for any object that has a collider. Now, in the next video, we're going to take a look at how to distinguish between other objects in the scene, right? Because currently we can interact with the walls and the floor, and we don't want that. We want to be able to interact with the objects that we want, not everything. So what we'll do in the next video is set up what is called a component. We're going to add an interaction component that we can add to any object in our scenes and make them interactable. All right, guys, if this tutorial was helpful, consider a like and subscribe to the channel, as we're going to be covering a lot more. Thanks to all of my patrons who keep this series going. You too can get access to the project source files by joining my Patreon. You can download everything there, and you'll also get early access to my videos and sneak peeks at future tutorials. Thanks for watching, and as always, keep creating.